Hey everyone, and welcome. If you've ever been caught in that tangled mess of software releases and server setups, you know exactly what I'm talking about. It's a special kind of frustration, right? Well, today we're diving into the solution: configuration management, the discipline that brings some much needed order and, frankly, sanity to all that chaos. Okay, we have to start with the classic, painful question. It's the phrase that's probably haunted every developer at some point, right? But it works on my machine? Yeah, that one. This single problem is the perfect way to understand why configuration management isn't just, a nice to have. It's an absolute necessity in tech today. And yeah, this image pretty much captures that exact feeling of despair. So what's the deal? Well, the root cause is almost always a tiny mismatch between environments. Maybe your machine has one version of a library and the production server has a slightly different one. These tiny little inconsistencies, they create massive, unpredictable problems that are an absolute nightmare to track down and fix. And you gotta remember, before the tools we have now, setting up big infrastructure was just a manual grind. I mean, imagine this. You're logging into hundreds of different servers, one by one, typing the same commands over and over, just praying you don't make a single typo. The whole process wasn't just slow and boring, it was super risky, and just begging for human error, which always leads to fragile, inconsistent systems. And what happens when one of those manual updates inevitably goes wrong? Well, rolling it back, that was next to impossible. You couldn't just rewind to the last good state. It was like trying to unscramble an egg, like the image says. You were stuck on this one-way street of patches and hotfixes, and the whole system just got more complicated and more unstable with every single change. So, out of all that chaos, the hero of our story finally arrives: configuration management, or CM for short. Let's dig into how it actually solves all these problems. I love this puzzle metaphor because it's just so perfect. Think about all the parts of your system: the servers, the databases, the networks, the apps. They're all like scattered puzzle pieces. Configuration management is what gives you the blueprint, the picture on the box that tells you exactly how those pieces are supposed to fit together to create one consistent working whole. And here's the really crucial part. CM isn't just a one-time setup. It is a formal, ongoing process. The whole point is to establish a known, reliable state for your system, and then to very carefully manage every single change from that point on to make sure it stays stable and consistent over time. So how is this all done? Well, it's through this really powerful idea called infrastructure as code, or IAC. Now, instead of manually clicking buttons in a console or typing commands, you define your entire system. We're talking servers, security rules, load balancers, the whole shebang, in code, in simple text files. And that code becomes your single source of truth. Suddenly, your whole setup can be versioned, repeated, and automated, just like your application code. It's a game changer. Okay, so we've covered the what, but how does it all actually work in practice? Let's take a look at the blueprint for how these systems actually establish and maintain control. Generally, the whole process breaks down into 4 core activities. First up is identification. That's where you define and label every single piece of your system. Then you have control, which is all about setting up a formal process for how any changes get reviewed and approved. After that, there's status accounting, which basically keeps a running log of every single change and the system's current state. And finally, you have auditing, which is where you check to make sure the system in reality actually matches the plan on paper. You put all those together, and you get a super reliable, trackable system. All right, so while the end goal is always the same, the tools that actually do all this stuff, well, they usually take one of 2 main approaches to get the job done. And this diagram really lays out the 2 main models perfectly. On one side, you have the push model. Here, a central server actively reaches out to all the other machines, the nodes, and pushes the configuration changes out to them. This is awesome for when you need to make immediate, on-the-fly changes. Then you have the pull model. In this setup, each individual machine is responsible for checking in with the central server and pulling down its own latest configuration. This approach is often way better for handling huge scale and making sure everything stays consistent over the long run. So, we've gone through the what and the how. But what's the big payoff here? I mean, why do companies invest so much time and money into getting this right? Let's talk about the benefits, because this is where it gets really good. And the advantages they're huge. First off, by automating all those tedious manual tasks and finally killing that "it works on my machine" problem, productivity just skyrockets. Errors get drastically reduced. Team collaboration gets way better because everyone is working from the same playbook, the code itself. And all that speed and reliability, that's what fuels the agility you need for modern DevOps. Plus, it even helps automate security and compliance by making sure your systems are always in a known, approved state. And this quote really says it all, doesn't it? Let's be crystal clear. Configuration management isn't just some optional add-on to DevOps. It is the absolute foundation. It's the bedrock that makes all the speed, automation, and reliability of modern software development even possible to begin with. All right, so we've been talking about a lot of concepts and ideas. Let's get a bit more concrete now and actually meet the real-world tools that engineers use to make all this stuff happen. And believe me, there's a whole ecosystem of these tools out there, and each one has its own unique strengths. You'll hear names thrown around like Ansible, Puppet, Chef, and SaltStack. Now, while they all might do things a little differently, they're all aiming to solve the exact same core problem: how to automate and manage infrastructure. To make this even more real, let's zoom in and compare two of the biggest players in the game, Ansible and Puppet. Putting them side by side is a fantastic way to see how those push versus pull philosophies we just talked about actually play out in the real world. Okay, here's the main difference in a nutshell. First, you've got Ansible. The deal with Ansible is that it's push-based and agentless. What that means is you don't need to install any special software on the servers you're managing. It just uses a standard SSH connection to push out commands. Super simple to get up and running. Now, Puppet, on the other hand, is pull-based. It uses what's called a master agent architecture. You install a small piece of software, an agent, on every server. That agent then regularly checks in with a central Puppet master to pull down its configuration. It takes a bit more setup at the start, but it's incredibly powerful for managing the state of your systems over the long haul. And listen, these aren't some niche, obscure tools. We're talking about technology that powers some of the absolute biggest names on the planet. Puppet, for example, is used by giants like Google, Spotify, and even the US Air Force. And Ansible, with its simplicity, has seen just massive adoption across pretty much every part of the tech industry. This is serious, enterprise-grade, battle-tested automation we're talking about. So there you have it. We've seen how configuration management brings order to the chaos by literally turning infrastructure into code. And this whole trend of automation, it's only getting faster, which kind of makes you wonder, right? As we keep getting better at translating these incredibly complex systems into simple, manageable code, what's the next big, human, complicated task that's going to be simplified and automated away? I'll leave you with that to think about.